In this video, we'll talk about how to graph natural log, and we'll talk about some properties of the natural log. So in order to do that, let me show you the graphing calculator. So on your graphing calculator, there's a couple of buttons that you need to kind of know about: the natural log button and the log base 10 button. These are the two ones listed right here, next to 7 and next to 4. Okay, they're found on pretty much all the TI calculators. The location might be different on the TI 83. I'm using an 84 right now, but they're virtually all right there on that side. Okay, now to graph the function, we're going to go to the Y menu, and we're going to type in ln, that's the natural log, and then x, and then close the parentheses. Once we do that, we should be ready to go. I'm going to click zoom 6, and that will turn it into the standard window, and that's the general idea of the graph. Okay, so once you have the general idea of the graph, that's pretty much it. You're just going to need to bring it to your paper and plot the points, and you're basically finished. In order to graph this a little bit more accurately, we're going to extract some numbers from the graph. So I'm going to click on trace, and I'm going to click 0.1 for example, and see what the y-coordinate is going to be like. So negative 2.3. So I'll record that on a piece of paper. Then I'm going to trace, maybe 0.5, and then get a different value, and so on and so forth until I have enough points to graph the function. Okay. By the way, if I plot e, if I trace e to the power of 1, that means it's e, I will end up with 1. So e is 2.7 roughly, and the y-coordinate is 1. So let's take those points that we just found on the TI calculator and plot them on this grid. And the very first point that I know of is that the graph was passing through 1 and 0. The other point was e, which is roughly 2.7, and the y-coordinate was 1. And I know that at 0.1 it was roughly negative 2 point something, so it's going to be down here kind of. You could do additional points to get the general idea, but basically the graph is going to have a vertical asymptote that runs like this. So this is a line that acts like a border. Make sure you do not cross it. And then the curve is going to look pretty much something like this. Okay, so let's plot the points, graph them, connect them, and we'll be basically finished. So as you can see, the graph is pretty much gonna be concave down all the time. So the graph is concave down. It is always increasing. So no matter how you look at it, if you're walking from left to right, you're always going uphill. So I'm gonna say the graph is increasing. The graph crosses the x-axis at the point 1, 0, and it passes through the point right there where e is 2.7 and the y-coordinate is basically 1. And the domain is pretty much only 0 to infinity without including 0. So the domain, basically the list of the numbers that are allowed as inputs, is the numbers between 0 and infinity, but it does not include 0 or infinity. This is the reason why we had that border pretty much at 0. Okay, the graph does not include 0 itself, and as a matter of fact, we call that border the vertical asymptote. So that's the graph of x equal to 0. Okay, so that's a VA. In other terms, it's a virtual, pretty much like a border that prevents the graph from moving a little bit more to the left. And the range on this graph is pretty much all real numbers. The graph starts down at negative infinity and it goes up forever. So that's the reason why the range is going to be from infinity to infinity. So the range is from negative infinity to positive infinity. And that's pretty much the analyzation of the graph. So what I would like you to know from this whole discussion and remember is that the graph of logarithms pretty much starts very, very steep, and it ends up being sort of kind of horizontal towards the end. So that's the general idea of the graphs of logarithm. This is why we like them, because they take really big numbers like 7, 8, 9, 10, whatever, and the y-coordinate is very, very small for a long, long time. Okay, so the logarithms have that special property where the input can be very, very large, but the output is very, very small, typically speaking.